Good morning to all the students. So today we shall have a discussion in connection with the measuring systems used in case of a CNC machines. So as you know very well that the CNC machines are basically designed to carry out all the operations automatically. So in order to achieve the production rate properly, and also in order to achieve the accuracy of production, it is necessary to design the proper electronic measuring system in case of CNC machines. So along with that, the CNC machines are also designed to carry out the tool gauging process and the tool monitoring process. So there are three important aspects which are being carried out automatically on the CNC machines, unlike manual machines. Because in case of manual machines, whenever any operation when you are going to do, immediately before and after a particular operation, okay, the operator need to measure, the operator need to set the speed rates, or the operator needs to give the feed rate manually. But this is not going to happen in case of CNC machines, as once the tool is the tool and the workpiece are set properly into the CNC machines, every action or every operation has to be carried out automatically in case of CNC machines. So now in the today's session, we shall have a detailed discussion how a CNC machine is designed to carry out the process of measuring the movement of the table in X and Y directions, and also the rotational speed of the workpiece, how this is monitored and how this is measured. So that is all what we are going to discuss in the today's session. So in the today's session, we shall have measuring systems, and what are the methods of measuring systems used in CNC, gauging and tool monitoring system, and what are the types of tool monitoring systems used in case of CNC machines. So as all of you going to see very clearly in detail, just I am explaining, please try to concentrate on that. So here the measuring systems basically consists of the two important systems. So one is called as a direct measuring system, and this is called as a indirect measuring system. So our concentration is first understand what is the meaning of a measurement system. It is nothing but an electronic measuring system adopted in CNC machines. Just I have told, so whatever the system is there, it should be carried out electronically. That means we require to use basically the sensors, which you have already studied in case of mechatronics subject. Okay, different types of sensors which are used for the purpose of measuring, monitoring the displacement, especially the sensors used in case of CNC machines for related to the movement. Okay, they are called as position or displacement sensors, which are used for the purpose of taking the measurement of the movement of the table or the rotational speed of the workpiece or the cutting tool, okay, by using the encoders, which we have discussed in length in the previous course, or that means in the previous semester in the subject of mechatronics. So each controlled axis is monitored, measured, that moves the slide or the table or the rotational speed of the tool. There are few important considerations here. So the axis is always controlled, means so, and each axis is provided with the servo motors known as feed motors. Okay, so these feed motors are going to get the control signal from the control unit of a CNC machine, and it is responsible for giving the proper movement to the table or the slide or the rotational speed of the tool or the workpiece, whatever is there. So as you are going to see very clearly here, okay, so there are two types of systems which are important. This is called as the direct and this is called as an indirect measuring system, which we are going to discuss in length in the subsequent presentations. So let us understand why the measuring systems are used and what are its functions. That is very, very important before we proceed in detailed in connection with the methods of measuring systems adopted in case of CNC machines. So the most important thing that you need to understand here is monitoring the position of a slide on a slideway. So there are two important aspects here because while discussing about the guide and guideways, the same concept is also coming into a picture here. So there are two important things. So we require to use the feed motor, or that is servo motor, that is in connection with the ball screw which is not shown here. Okay, and that ball screw is in connection with the table. So the rotational speed of the motor is converted into linear movement of the cutting tool or the table, whatever is there. So we need to understand here how this movement is going to take place. So for that purpose we need to understand what are the methods being used. Okay, so to compare the position of the slide and the spindle with the desired position, so we require to set a certain position, then we require to take the measurement with respect to that, whether the table is made to move in x direction, in y direction, that too in the positive side or in the negative side. So all these are graduated on a surface of a table, which you are going to see there clearly here. So this is called as an engraving. So these are called as a graduated scale which is provided, and this is a sensor which is going to sense, and that signal is sent to the control unit to take the necessary action in connection with the movement of the table, whether it is carried out as per the programming instructions. So the third important function is to orient the spindle or the table. That means to orient means what? To position it properly, okay, as per the programming instruction. That is very, very important. To measure the speed of the spindle, even the speed of the spindle, whether in a spindle either we can accommodate cutting tool or we can accommodate workpiece. So we require to take the rotational speed of these cutting tools. Okay, that measurement is also carried out by the measuring system to eliminate the tool wear errors. So this is one more important concept as far as the automatic machining is concerned. The operator is not going to take out the cutting tool or the cutting edge of a cutting tool, okay, or the tool bits in order to check its the efficiency of the cutting ability of a cutting tool. So there is an automatic monitoring system is there for the tool wear and tool breakage, which also we are going to discuss in length in the subsequent presentation. To eliminate the deflection due to misalignment, this is another one. So whatever the misalignment is there in connection with the movements, so that can also be eliminated with the help of the measuring system to avoid the interference caused by the presence of swarf and the cutting fluid. See what happens, swarf means basically the metal chips which are cut, okay, and the cutting fluid should not disturb or should not interfere in the process of measuring the movement or monitoring or taking into consideration or sensing the movement of a table or a slide. So, okay, so these are some of the important functions that the measuring systems are being designed in case of a CNC machines. So now let us go in detail in length with the measurement systems which you are going to see here. So now here we shall have, this is called as a work table provided with the T-slots, and this is a y-axis direction and this is the x-axis direction which is indicated here, and such a system we call it as a direct measurement system. So why it is called as a direct measurement system? But before that we need to understand certain components which are used here. So the one important part, number one, we call it as a pickup. Pickup means what? It is basically a sensor, position sensor, which senses the position or the movement of the x-axis. Similarly, the same one is also provided here, but which were not shown. So that means how many axes are there, so many sensors need to be incorporated in a case of a CNC machine, and these movements are monitored and they are also synchronized, and that signal is sent to the control unit to carry out the process of measuring or to taking the control action, whether especially in the case of a closed loop control system. So that is what we have discussed while discussing in length in connection with how the sensors are used for the purpose of taking the sensing, okay, and how the error is rectified and how it is amplified and how it is used for the purpose of correct measurement of a system. Okay, that is very, very important. So now we need to understand here the point number 2 is called as a glass ruler with scale. So this is basically, as we are going to see, these are called as the graduated scales are there, perfectly graduated scale on which there is a direct sensor is kept for monitoring the position or the movement of a table. So such a system we call it as a direct measuring system. That is very, very important. Measuring device is fixed into the moving machine element to detect the actual distance traveled by the machine slide. So whatever the movement of this slide is there, the movement of the table or the movement of the slide is directly measured on a table itself. So that is why it is called as a direct measuring system. To measure the linear displacement directly at the slide, no effect of backlash errors on the measurement. So this is also one of the most important. So you need to understand what is the meaning of a backlash. So backlash is a type of the improper positioning is nothing but a backlash. So whenever there is a mechanism where we are going to convert from rotary motion into linear movement, okay, even if the lead screw or the ball screw is made to rotate, you are not going to observe the proper movement of a linear element or a table. So such a drawback error we call it as a backlash. So here there is no question of a backlash because as the measurement is taken directly on the machine table itself. Okay, achievement of high degree of accuracy. So you can achieve a highest degree of accuracy as the measurement is taken with the help of displacement or position sensors directly on the machine table of a CNC machines. So the same one it is already shown here as you are for better understanding of the concepts. So this is called as a scale, which whatever the scale which is marked here. So this one you are going to see here clearly as you are the same markings has been slightly shown in a magnified way for the better understanding of this concept here. The same scale is shown here also, how this scale is being designed. So this is called as what we can say it as a graduated electronic graduated scale, okay, on the machine table surface itself, okay, which is directly fixed on it for the measurement. Okay, that is such a system we call it as a direct measurement system. Okay, so the next one coming is indirect measurement system. So unlike a direct measurement system, the measuring of the movement of the table or the slide, if taken directly by using the graduated scale and sensor, we call it as a direct measuring system. If this is not done, then we require to use again photo sensors. So that is what you are going to see here very clearly. So now this such a system we call it as an indirect measurement. So what we do here is we have got the encoder disc. The rotary encoders are provided on a shaft, and the part number 3 is called as a spindle, and it is in connection with your ball screw. So finally what we are going to do here, we are going to mount one encoder, okay, and on one, and this is the part number 1 is called as a carrier. Actually the carrier is nothing but a photo sensor. So as we have already discussed in the mechatronics subject also, these encoders are going to have the slots here, okay. On one side you are going to have the continuous source of light, and on the other side you have got a pickup to sense the movement of this. So as the encoder rotates according to that spindle, or the ball screw starts rotating, and that is responsible for giving the movement in x-axis. Similarly, the same process is also followed in this direction for the y-axis also, that we have not shown for better understanding of the concept. So why this is called as an indirect measurement, that is need to be understood here. So first we require to give a rotational motion to the ball screw or the spindle. Then this rotational motion is converted into linear movement of a work table of a CNC machine. Okay, so now what is going to happen here? We are converting rotary motion into linear motion of the table. So such a mechanism is nothing but a simple screw and nut mechanism. So finally, whatever the movement of the x-axis purely depends upon the rotational speed. So there is every chance that the backlash errors may exist. So that is why this system is definitely slightly inaccurate compared to the direct measurement system. That is very, very important here. So slide position determined by the rotation of the ball screw or the pinion or the drive motor. So we need to understand here the drive motor or the feed drive motor, also known as a servo motors. They are in connection with the spindle, okay, and directly to the ball screw, and the ball screw is in contact with your slide or the table. So as the ball screw rotates, there is a linear movement of the table or the slide. Okay, so this is how the process is going to take place in case of an indirect measuring system. It is having a low degree of accuracy. Why it is having a low degree of accuracy? Because the movement of the ball screw decides the linear movement of the table. For that purpose, backlash errors in axis drive elements and torsional errors affect the measurement system. There are two important errors here. One is called as a backlash, another is called as a torsional errors. That means even if the balls we are going to provide the correct mechanical power to the ball screw, there is every chance that there are certain losses, okay, in case of power transmission. Okay, so that is why it is called as a torsional errors that can exist in case of an indirect measurement system. More convenient and less costly. So but it is very convenient and less costly. Why it is called as a convenient? Because in case of a direct measurement system, whatever the metal chips which are cut, they may affect the surface of the table, because that table, at the side of the table, there is a provision of a graduated scale. So there is every chance that this graduated scale may not be visible for the sensor. That is one of the drawbacks in case of a direct measurement system. But in case of an indirect measurement system, such a problem does not exist. So that is why it is called as a more convenient and less costly. Various error compensation features are available. That means whatever these errors like backlash, torsional errors can be rectified directly by using the automatic provision in case of a CNC machines. So these are considered as very, very two important aspects whenever the measurement is to be taken in case of a CNC machines. So now we need to understand one more important concept here. So whenever you are going to carry out the manual operation, first of all, you are going to take all the dimensions of the given raw material. Then you are going to fix the workpiece on a headstock chuck if you take a simple lathe machine. Okay, then you are going to start your operation. Then again you are going to take out it for the measurement. One particular operation is being carried out. So this is a manual continuous process, but such a process is not available in case of a CNC machine. So we need to understand that as a CNC machines are basically automatic machines, and we require to provide a automatic gauging system, okay, with the help of one device known as a trigger touch probe. So as the name itself indicates, again it is an electronic measuring system by which it is possible to detect the position of the workpiece, whether the workpiece is mounted or not, or is there any problem with the workpiece itself regarding its surface. Okay, and even for the finished job can also be measured properly with the help of the touch probes, which we are going to understand now in this presentation. So such a system, generally we call it as a gauging system. Gauging is nothing but a process of measuring properly. So as you are going to see, so we require to use a sensor here. So as that is nothing but a piezoelectric element. So these piezoelectric sensors we have discussed, or even you can go for a wire resistance strain gauge, which is provided within the uh, trigger probe, which is used for the purpose of measuring the surface of the workpiece for its fracture, cracks, or even the tool wear, which we are discussing in the subsequent presentation. This is a simple sketch. So this is called as a pointer, which is used, and this pointer will be in touch with the workpiece for the workpiece detection, as well as to check all its surfaces whether it is present or not. So let us understand what is exactly the meaning of a gauging process. Gauging is a method or a process used first to inspect the presence of the workpiece, because though the operator is going to, once the workpiece is mounted, then it has to be sensed whether it is present or not. So that function is also carried out by the gauges: automatic alignment of the workpiece and detection of the stock variation. So automatically the alignment should take place for the workpiece properly, and detection of stock variation means detection of whenever the process, a particular operation is being carried out, then how much amount of material is removed, so according to the next dimension. So that measurement is taken by these gauges only. To define the tool offsets and tool breakage, so whatever the tool offsets, tool offset means what? The tool is mounted in a turret head, and that whatever the distance is there in the respective axis, so that will be stored in the control system with the help of a control panel. Okay, so such a system is nothing but what? Giving the offset value to the tools, so that the tool can carry out the machining operation properly. And also for the tool breakage, is there any tool breakage is there, to maintain the better quality of the workpiece. Even the workpiece quality can also be maintained properly if a proper gauging system is used. To eliminate the tool wear and thermal growth by using an automatic gauging system. An automatic gauging system provides, okay, the detection of the thermal growth, that is the increase in the temperature of the whenever machining operation is being carried out, or is there any tool wear or the cutting edge wear being detected. So that all function is carried out by a system known as a gauging. Now again, for a better understanding of the concept here, so you are going to see the pointer which is made to move is called as a stylus. It is actually a pointed. This surface will be made to contact the workpiece surface as well as for the tool surface for its detection, for its presence. Okay, and whatever this stylus, whatever it is going to sense, it can be converted into an electronic measurement system for the purpose of measuring, okay, the initial as well as the final dimensions of the finished job for its accuracy purpose. A touch trigger probe is used for the measurement and inspection. So whenever we want to carry out the inspection of the workpiece detection as well as inspection of the finished component, we require to use a touch trigger probe. So we require to bring this element known as a stylus, and these are called as a pointer, which is allowed to touch to the surface of a workpiece or the cutting tool in case of a CNC machine for the purpose of measuring. It may be a tool wear or it may be accuracy also. A probe is basically a very sensitive switch. It is called as a sensitive switch with a long spring loaded stylus. You are going to see clearly here, there is a spring loaded stylus is there, okay, capable of detecting the small deflections of the stylus from the home position once the contact is made. So first of all, we require to bring this surface to contact the workpiece, and that is stored in the control system and used for the purpose of detecting the deflections present, transmits the signal to the machine system that processes the data as per the gauging requirements. This is very important. And the probes are mounted on the turret table. Generally they are going to be mounted on the turret table or headstock housing, okay, in case of a CNC turning centers, or can be transferred from the tool magazine to the spindle for use. So these are the three important methods through which the probes can be used for the automatic detection or inspection of the tool and the workpiece. So such a system we call it as what? Automatic gauging system. So now apart from that, the main purpose of using this touch trigger probe, okay, is to detect the workpiece inspection, and at the same time it is provided to see that whether the tool which is used for the purpose of machining, is it working correctly or not, or whether the cutting tool is present or not, even the workpiece is present or not. Along with that, the automatic tool monitoring system is also present in case of a CNC machines. So we require to understand one important concept here. As the CNC machines are made to run continuously, the operator need not have to check the efficiency of the cutting edge. So there should be an automatic tool monitoring system. That tool monitoring system automatically detects, okay, the deficiency in the cutting edge or the cutting ability of the cutting edge of a cutting tool, and it is going to represent, or it is going to give an alarm, or it can going to give an indication to an operator that the cutting tool need to be replaced. So such a system we call it as a tool monitoring system. Okay, so the main purpose of tool monitoring system is a process of determining the tool wear or tool breakage. So there are two important concepts here. The tool can be subjected to a wear. This is one possibility because of continuous operation, machining operation, and the next one is there is every chance due to continuous operations even the tools may break. So these two things or these two concepts have to be controlled or has to be observed properly by an operator. Tools wear out due to continuous operation of CNC, which leads to the poor quality of the workpiece. So due to the poor quality of the workpiece, that itself represents there is some problem in the tooling systems. It affects the productivity of the machine and the quality of the component produced. Once the tool wear will exist, then there is every chance that the finished component is not according to the expected accuracy that is considered. So measures to be taken for this, how it can be considered, how we are going to take the measurement, detection of the tool breakage at the correct time. We require to take the proper proper decision in connection with whether the tool has to be replaced or whether any other modification or any other step can be used so that there is a continuous production in case of a CNC machine. So that is detected of the tool breakage at the correct time plays a very important role for the proper functioning of the tools, as well as the detection of the tool wear, whether the tool has got the cutting edge of the cutting tool is having any problem in connection with, or whether it has lost its efficiency in connection with the machining operation. So this can also be carried out automatically in case of a CNC machines. So we need to understand here the two important methods. There are two important methods used. One is called as a direct tool monitoring system, and the second one is called as a indirect tool monitoring system. So we need to understand in detail about these concepts. So direct tool monitoring system, here an offline tool monitoring system. So how you are going to do manually, the same process is followed here. The CNC machines are made to run. So once they are made to run for a certain hours, then the operator himself has to take out that cutting tool and inspect for its tool wear. So such a system we call it as a offline system. So in case of an offline system, So what he is going to do, he is going to use a certain microscope or any other methodology through which he can detect its deficiency, and in that condition he may need to go for the replacement, or he may continue with the same process with a grinding or whatever is there. But generally in case of a CNC machines, the entire, because all the process is carried out by the tool bits which are having different edges, there is every chance that an operator need to replace it completely. Monitoring the tool condition directly by the touch probe. So the touch trigger probe is used directly on the cutting edge surface for detection of its breakage. Okay, by an electronic system, it is going to act like a sensor which can sense and which can indicate on a monitor itself. Directly checking the tool edge position and checking the existence of a tool edge, that is contact sensing, and no system alarm to an operator to change the tool. There is no alarm system is there. Decision making system is manual one. So whatever the decision is taken has to be carried out by the operator. But definitely if you are going to consider this, so in such a condition the CNC machines cannot be used continuously, so as it is going to hamper the production. So definitely the indirect tool monitoring system is the most commonly used as far as the automatic operation is being concerned. So an indirect monitoring system, it is called as an online tool monitoring system. So it is an online, so once the operation which is carried out by the CNC machines, if there is any problem in case of a efficiency of the cutting tools, there is an automatic indication on the monitor in front of an operator to with the number of a tool that there is some problem exists. So the operator can have a visibility and he can take the necessary action in connection with that. So such a system we call it as a direct tool monitoring system, indirect tool monitoring system. Monitoring the tool condition indirectly by monitoring the change in certain parameters. So how this is done? So we require to understand what are the problems associated once the tool wear exists. Once the tool wear exists, the production of heat increased, the power loss is there, you are not going to get the proper accuracy of the workpiece of the job goes down. So all these are indirect parameters through which it is possible to consider that there is some problem exists in the cutting edge of a tool and need to be replaced. Observing the conditions such as tool life, power of the spindle or the feed drive, okay, forces due to cutting, and noise emission. Even noise emission could be the reason, or could be the reason for the tool wear, as which you are going to experience even on a lathe machine. If you are going to give a high depth of cut, there is a sound like that even on a CNC machines. So as the tools are used continuously, so whatever the noise emission that an operator is going to sense or the operator is going to hear, from that also he can make out there is some problem existing in case of a tool operation, cutting edge operation. An alarm system indication for the change of the tool, just I have told, and as it is an online, so automatically then alarm will be there which can indicate that there is some problem exists in the case of a tool functioning. So control system decides the condition of the tool. So whatever the condition of the tool, whether all the tools which are mounted on a turret head or in a tool magazine or which are used for the purpose of machining, are they functioning properly or not, that entire decision is taken by the control system of a CNC machines. Okay, so this is how the two important types of tool monitoring systems are being used in case of a CNC machines. So as per the discussions, we need to understand here what are the important questions expected to come in the examinations. List the methods of measuring system, that is what we have discussed, direct and indirect, and explain about the gauging, so that also we have discussed, and explain tool monitoring system, what is the meaning of a tool monitoring system, and compare direct indirect measuring system, compare direct and indirect tool monitoring system, identify the function of a measuring system which are used in CNC machines. So what are the important functions of a measuring systems used in case of a CNC machines, which we have discussed in length in connection with the measuring system as well as the tool monitoring system, which is also very, very important. And along with this, I am also going to connect with some of the important videos that which can clarify or which can give a better understanding of the concepts. Okay, with this I am going to finish off my presentations. Okay.